My dear students of Standard 10, good afternoon everyone. Dear students, this is your chemistry class. Welcome to my class. Today, in this class, we will discuss about rate of reaction and Chatellier's principle from chapter 7 of your chemistry book. At first, rate of reaction. What is rate of reaction? Rate of reaction means how fast a reaction is taking place, and it is measured with time, the change of concentration of product or reactant with time. Now, you know, when a reaction is started, then the concentration of product gradually increases and the concentration of reactant gradually decreases. So, the rate of reaction is defined as the decrease of concentration of reactant or increase of concentration of product in unit time is called rate of reaction. Unit time means in 1 second. Here time is measured by second. In 1 second, the decrease of concentration of reactant or the increase of concentration of product is called rate of reaction. That means rate of reaction equal change in concentration of reactant or product divided by time needed for that change. And rate of reaction also can be defined as the amount of products produced from reactants per unit time is called rate of reaction. You can write any one definition from there. It can be written or it. Now, unit of rate of reaction. Rate of reaction is the change of concentration of product or reactant with time. So, the unit will be concentration divided by time. The unit of concentration is mole per liter and it will be divided by second. So, the unit of rate of reaction is mole per liter per second. Mole, liter inverse, second inverse. This is the unit of rate of reaction. Now, rate of reaction depends on temperature. With temperature, the rate of reaction is increased. So, when temperature is increased, rate of reaction is also increased. And when temperature is decreased, rate of reaction is also decreased. It is the relation of rate of reaction with temperature. Now, chemical equilibrium. Dear students, chemical equilibrium, this term is applicable only for reversible reaction. You know, in reversible reaction, there are two reactions. One is forward reaction and another one is backward reaction. In reversible reaction, when reactants react to make product, then this part of the reaction is called forward reaction. And when the product becomes again reactant, then this part of the reaction is called backward reaction. And in reversible reaction, at the beginning of the reaction, the rate of forward reaction is very fast and the rate of backward reaction is very slow. But with time, the rate of forward reaction becomes decreased and the rate of backward reaction becomes increased. And one time will come when both the rate of forward reaction and backward reaction become equal. This time, this moment of the reaction is called chemical equilibrium. So, when the rate of forward reaction is equal that of the backward reaction, then the state of the reaction is known as chemical equilibrium. For example, this is a reaction where A and B are the reactant and C and D are the product. In this reaction, here forward reaction is A plus B, C plus D. That means where A and B produce C and D, this is the forward reaction, and the backward reaction of this one is C and D react and they produce A and B. And in chemical equilibrium, the rate of both reaction is equal. That means the rate of forward reaction equal the rate of backward reaction. Now, this chemical equilibrium can be represented by graph. In graph, we can put the forward reaction rate and backward reaction rate, and we will get this type of graph. Look, this is forward reaction rate, where this is in x-axis, in y-axis this is rate, and x-axis this is time. When at the initial of the reaction, the time is very less. Initial of the reaction, the rate of forward reaction is very high, and with time the rate of forward reaction becomes decreased. And look, this is backward reaction. Here at the initial, the backward reaction rate is 0, but with time the rate of backward reaction becomes increased. And in this moment, when the rate of forward reaction and the rate of backward reaction becomes equal, this is the state of chemical equilibrium. Look, where if you put the amount, the concentration of reactant and product in y-axis, and in x-axis it is time, then look, with time the concentration of product, with time the concentration of reactant, it is very high, because then all are the reactants and no product is produced, so the concentration of product is very low here. But with time the concentration of reactant decreased, and with time the concentration of product increased. But here the concentration of reactant and product, there are no change of their concentration, because this is the equilibrium state, where it seems that the reaction is stopped, but actually the reaction is going on. The reaction is not stopped here. Here the reactants produce product, and at the same time the product again produce reactant. So here we will get the mixture of reactant and product, and we will not get any more product from this state, from the equilibrium state. It is the mixture of reactant and product. This is also a graph of graph of equilibrium. Here the rate of reaction is in y-axis, and x-axis it is time. This is the rate of forward reaction rate, and this is backward reaction rate, and this is chemical equilibrium state, where both the rate becomes equal. Now, Chatelier principle. Chatellier's principle, this is also applicable for reversible reaction and when the reaction goes into equilibrium. What is the principle? Look, at the equilibrium of reversible reactions, if any of the factors, there are three factors, they are temperature, pressure and concentration of reactant, is changed, the equilibrium position will shift in such a way that the effect of factor is neutralized. What is Chatellier's principle? Already we know that when a reversible reaction goes into equilibrium, then forward reaction rate and backward reaction rate becomes equal, and we will not get any more product from the equilibrium state of a reversible reaction. But in this equilibrium state, if any factor, temperature, pressure or concentration of reactant, if any one of them are changed, then the reaction will go in such a way, either forward reaction rate will be increased or backward reaction rate will be increased. That means the equilibrium position will shift so that the change of factor will be neutralized. Now, this Chatellier's principle we will read in details. At first, you have to know why Chatellier's principle are applied for a reversible reaction. Dear students, from any reaction, we want to get product. There are some important reactions in industry. For example, ammonia production. When nitrogen and hydrogen react, they produce ammonia. Ammonia is an important ingredient of fertilizer industry. So, in fertilizer industry, the production of ammonia is very important. So, when this is a reversible reaction. So, when the reaction goes into equilibrium, then if we will not get any more product from the reaction, then it will be not beneficial for the industry. So here Chatellier's principle is applied for getting more product from the reaction. But we have to know that temperature, pressure or concentration, how is it changed? Temperature will be increased or decreased. So in this class, we will learn about this. At first, effect of temperature change on equilibrium. This effect of temperature, it depends on the exothermic and endothermic reaction. If the reaction is exothermic, then the change of temperature will affect in one way, and if the reaction is endothermic, then the change of temperature affects on another way. So at first, for exothermic reaction, dear students, already you know the reaction where heat is produced is called exothermic reaction. And exothermic reaction we will understand by seeing the reaction in this way, where it is given that del A is equal minus energy. Del A is, when the value of del A is minus, that means it is exothermic reaction. In this reaction, heat energy is produced. Now, dear students, look. In this reaction, here heat energy is produced. That means it is a reversible reaction. When ammonia is produced from nitrogen and hydrogen, this forward reaction produces heat. Another way, if the backward reaction, when ammonia is decomposed to produce nitrogen and hydrogen, this backward reaction, it is endothermic reaction. In this reaction, it absorbs heat. That means reversible exothermic reaction. In reversible exothermic reaction, forward reaction is exothermic and backward reaction is endothermic. Here, it is the combination of these two reactions. In one reaction, ammonia is produced, that is called forward reaction, and in another reaction, ammonia is decomposed, this is called backward reaction. And this forward reaction, this is exothermic reaction, this reaction produces heat, and this backward reaction, it is endothermic reaction. This reaction absorbs heat. Now, in this reaction, if heat is given or if temperature is increased, what will happen? Just think. When temperature is increased, then the reaction will want to, the equilibrium will want to minimize the increased temperature according to Chatellier's principle. If any of the factor is changed, then the reaction, the equilibrium will be shifted in such a way so that the change of factor will be minimized. So the increased temperature will be minimized, will be decreased. How? By occurring this backward reaction, because this forward reaction, it will again produce heat. It is exothermic reaction. So if in this condition forward reaction is occurred, then the temperature will be increased more, but the temperature should be decreased. By how? By occurring this backward reaction. That means for exothermic reaction, if the reaction goes to equilibrium, then if temperature is increased, then backward reaction rate is increased. Clear, dear students? Because this backward reaction is endothermic reaction, and this endothermic reaction absorbs the extra heat and it minimizes the temperature. Look, with increase of temperature, backward reaction is occurred. That means the backward reaction rate is increased. And backward reaction, which reaction? This reaction. Here in backward reaction, some ammonia will be decomposed to produce nitrogen and hydrogen. And this backward endothermic reaction absorbs the extra heat and minimize the increased temperature. And when backward reaction rate is increased, then equilibrium will shift into left side. Dear students, when forward reaction rate is increased, then equilibrium will be shifted in right side, and when backward reaction rate is increased, then equilibrium will be shifted into left side. So this reaction, it is an exothermic reaction. Not only this reaction, for every exothermic reaction, if temperature is increased, then backward reaction rate will be increased and equilibrium will be shifted into left side. And if temperature is decreased, what will happen? When temperature is decreased, then the reaction will go in such a way so that the decreased temperature will be increased again. How? By producing heat. How the reaction will produce heat? By occurring this forward reaction, because this forward reaction is exothermic and this reaction will produce heat so that the temperature will be increased again. So with decrease of temperature, forward reaction is occurred. Forward reaction means the production of ammonia. More ammonia is produced by the reaction of nitrogen and hydrogen. This forward reaction is exothermic. So this exothermic reaction produces more heat and minimize the decreased temperature, and equilibrium will shift into right side. So this is the effect of temperature change on equilibrium for exothermic reaction. I will give you another example that is also exothermic reaction. For exothermic reaction, we know with increase of temperature, equilibrium go to left side because the backward reaction rate is increased. And with decrease of temperature, equilibrium will go to right side. That means forward reaction rate is increased. Look, this is also an exothermic reaction because here also the value of del H is negative. So this is exothermic reaction. In this reaction, if temperature is increased, then the reaction will go to back. The backward reaction rate will be increased. That means some SO3 will be decomposed to produce sulfur dioxide and oxygen, and equilibrium will shift into left side. And if temperature is decreased in this reaction, then the forward reaction rate will be increased. That means more SO3 will be produced from the reactant SO2 and oxygen, and the equilibrium will shift into right side. There are some more examples also, and for every exothermic reaction, just you have to remember that when temperature is increased in exothermic reaction, then backward reaction rate will be increased because backward reaction will absorb the extra heat and the increased temperature will be minimized, and the equilibrium will be shifted into left side. And if temperature is decreased for exothermic reaction, then forward reaction rate will be increased and it will produce more heat. So the decreased temperature will be increased again and the equilibrium will be shifted into right side. Now, effect of temperature change on for endothermic reaction. Effect of temperature change on equilibrium for endothermic reaction. It just opposite of exothermic reaction, because you know in endothermic reaction the temperature becomes decreased, heat is absorbed in the reaction. So here the increased temperature will increase the forward reaction rate and decreased temperature will be increase the backward reaction rate. This is an example of endothermic reaction because here the del H is positive. Here del H equal 180 plus 180.75 kilojoule per mole. This is an endothermic reaction. Now it is also the combination of two reactions. Here the forward reaction is N2 plus O2 NO. That means the production of nitric oxide, it is the forward reaction, and the decomposition of nitric oxide, it is the backward reaction. Here the forward reaction is endothermic and the backward reaction is exothermic. Now in this reaction, if temperature is increased, then what will happen? If temperature is increased, then the increased temperature will be minimized. How? Should be minimized. How? By occurring the endothermic reaction. Which part is endothermic here? This forward reaction is endothermic. So when temperature is increased, then the forward reaction rate is increased for every endothermic reaction. So more nitric oxide is produced by the reaction of nitrogen and oxygen, and this forward reaction is endothermic, so it absorbs the extra heat and minimize the increased temperature. And we know when forward reaction rate is increased, then the equilibrium will shift into right side. And when temperature is decreased for this endothermic reaction, then the decreased temperature should be increased again. How? By occurring the exothermic reaction. This backward reaction of endothermic is exothermic reaction. So when temperature is decreased, then backward reaction is occurred. Some nitric oxide is decomposed to produce nitrogen and oxygen. This backward reaction is exothermic. So this exothermic reaction produces more heat and minimize the decreased temperature, and equilibrium will shift into left side. Now another example, another endothermic reaction. We know with increase of temperature for endothermic reaction, equilibrium will shift into right side because the forward reaction rate is increased, and with decrease of temperature, the equilibrium will shift into left side because the backward reaction rate is increased. This is the example of endothermic reaction where the del H is positive. Now in this reaction, if temperature is increased, then forward reaction rate will be increased. That means more phosphorus pentachloride will be decomposed to produce phosphorus trichloride and chlorine, and equilibrium will shift into right side. But with decrease of temperature, the product phosphorus trichloride and chlorine will combine to make more phosphorus pentachloride, and the equilibrium will shift into left side. This is just the effect of temperature on equilibrium of exothermic and endothermic reaction. Just you will see that the reaction is exothermic or endothermic, and for exothermic reaction the effect is in one way, and for endothermic reaction effect is completely in another way. Effect of temperature on equilibrium. If the temperature of the system is increased, then the equilibrium will shift in the direction of the endothermic reaction for every reaction. For endothermic reaction, the equilibrium will shift in forward way, and for exothermic reaction, the equilibrium will shift in backward way. And if the temperature of the reaction is decreased, then the equilibrium will shift in the direction of the exothermic reaction. For exothermic reaction, it is in forward direction, and for endothermic reaction, it is in backward direction. So dear students, today I have discussed only the effect of temperature on equilibrium. Next class, we will learn about another two factor, pressure and concentration, and also we will learn the industrial production, how the temperature, pressure and concentration will be changed, will be set for the highest, for getting the highest yield in industry. So today, up to this, goodbye everyone. Thanks to all. See you in next class.